Okay, we're going to continue talking about the atmosphere, and then that's the reason we have on the standard atmosphere, the atmospheric pressure is measured in 29.92 inches of mercury. So that's where the measurement of the atmospheric pressure in inches of mercury is the standard. You know, it comes from a long time ago when they figured out how to measure atmospheric pressure. The standard at mean sea level at 15 degrees Celsius is 29.92. And our instruments are calibrated, you know, to that standard. That's another representation of the barometer. Yes?
If we can't use mercury in a barometer anymore, how do we apply a barometer to a plane or to any?
There are new digital ways, you know, to figure, you know, to make those measurements. So there's no need for mercury anymore. Plus, you know, like in the aircraft, you're not going to have, you know, a mercury-driven barometer per se, but your instruments are calibrated to that standard. Okay, and then the atmospheric pressure is basically the weight of the column of air that is directly above you. The higher you go, you know, the less particles of air, you know, are above you, so less pressure. That's one of the reasons if we operate from a high altitude airport, I think Denver is at it's like 6,000 feet, you know, give or take. If I have an airplane at mean sea level, at standard temperature, and I take off, the amount of runway that it's going to take for me to achieve the airspeed needed to take off is going to be less. If I'm taking off from a high altitude airport because I have less air particles traveling through my wings, it's going to take a longer runway and a higher airspeed for me to get airborne. Yes?
Is air pressure what causes stalling of the engine, like if you're going up a certain height?
In part. If you don't have enough air particles, you know, to feed your engine, it will stall because you need three things: air, well, oxygen, the oxygen component of air, fuel, and spark. That's why rockets that go to space, they carry their own oxygen on board. And they mix it, and they can have propulsion.
Like
At
particulars, like sand and stuff. If you're like flying off of a desert runway or whatever,
Mhm.
and it goes through your engine, would that damage your engine?
yes, and it happens quite frequently. Airlines that operate from, you know, UAE, Saudi Arabia, they have their own schedule for maintenance and overhaul for the engines that they use.
Is there a way of like combating that, like stopping particles from getting in your engine?
Not really. You know, we get particles of sand from the Sahara Desert all the way here. They're that fine. You know, air currents bring sand particles all the way from the Sahara Desert, all the way, you know, everywhere in America, everywhere in the world, basically. So it's not really, you know, a feasible option. And what they try to do, obviously, they avoid operating if there's a sandstorm. But other than that, those are the conditions. You know, it's just maintenance cycles are just happen more often there, and it's kind of like their reality. If you have every 1,000 feet of altitude that you climb, you're going to have 1 less inch of mercury in your barometer. And then for every 1,000 feet of altitude, the temperature is also going to drop at a standard rate of 2 degrees Celsius.
What happens if the air becomes denser than sea level? Like, is that possible for the air to become denser than standard sea level?
There are areas that they you know, for example, the Death Valley is under sea level on altitude, and they have a higher atmospheric pressure there. What usually happens is that you have less weather, because weather tends to move towards areas of low pressure. You got it? Not yet. Too bad. Okay, when it comes to temperature, so the higher you go, you're not done yet? Oh, come on. That's okay.
We're trying.
Okay, so if you get water particles
In the engine?
the engine, would that affect it?
Yes.
I mean, it has oxygen.
No. Excuse me? No, not necessarily, because you have the temperatures that happen on the inside the engine is just going to evaporate that water right away. So you're just going to have like water vapor, you know, shooting through the back. It depends on the amount of water. Like some light rain, you can still, you know, produce thrust, and it's not going to be an issue. It becomes a problem when the amount of water that enters the engine extinguish the flame that got the engine going.
Also, when there's more water than air?
Yes. So you get rid of the flame of the, you know. Have you put water on a flame? What happens?
Nothing.
Oh, okay. Yes. You can make it worse. Yes. It does have oxygen, but it will depend on the type of fire that you have.
So, like pontoon planes, how does they?
Like they it's just like the ones that appear on TV, you know, with the giant fan in the back, or
The ones that land on water.
like the Everglade boats. Oh, yeah, the seaplanes. Seaplanes. Seaplanes, they have floats, and they usually have their engine mounted, obviously above the line, you know, of water. Most of them are propeller driven. Yeah, as long as the breather is located in a way that, you know, water is not going to get there. You can have, you know, just like you can have, you know, cars that can get submerged in water. You submerge the engine, but then as long as you have the exhaust and the intake out of the water, you're not going to have a problem. And so that's what happens, and that's just a graphical representation of what I just said. Trimmed half. Gotta be kidding me. So it won't show properly. That's the high altitude balloon that we launched. I don't care. You know what? Yes. Take a break. Well, I figured this one out. Take 10. So with that experiment, I want to add to the next experiment that we make a barometer so we can double check the standard lapse rate for atmospheric pressure per 1,000 feet, each one of those differences. And our new thermometer should get calibrated in Celsius. Okay, now we're going to talk about the pitot and the static system on the airplanes. The pitot tube, that's a component of the pitot static system that collects ram air data, collects ram air into the instrument, and feeds information to the airspeed indicator. It's usually mounted on the wing or on the nose of the airplane, and it has an opening on the front in order to collect air. It has a heating element to it as well. So in case you go into humid conditions at altitude and ice is likely to form, you can melt that. I have a friend who flies a helicopter, and he goes to this like really small villages in Honduras. And sometimes, it would happen that people will try to grab the pitot tube. And this is like a very sensitive component. So he will let because the pitot tube heater, it gets red. It's like that hot. So he will let it run for a couple of minutes after landing, just to make sure if someone grabbed onto the pitot tube, let it be known that it wasn't the best idea.
Why was someone trying
So,
to steal the pitot?
no, they weren't trying to steal it. They were just like getting close to the helicopter, like first time seeing a helicopter, and just trying to like touch it. It's like, oh, what's this? And just grabbing. And he had one helicopter damaged because of that. And then he had to wait for the part and maintenance personnel to replace it. So he added onto the checklist, just to let the pitot heater on for a couple of minutes, just to avoid having it damaged by people going into to check out the helicopter.
So where would it be on a helicopter?
It's usually on the nose.
So it's for a helicopter and
Yes, on an airplane, it's usually mounted under the wing or the nose, and then on helicopters, it's like right under the nose.
oh, and people would try to grab it.
Yeah, people will try to grab it. It was like on the nose of the helicopter, and they just say, "Oh, what's this?" It's like, "¿Qué es esto?" Right. Yeah. Okay. That's a switch that he would activate. An important question, and this is likely to go on your test. The pitot tube is only connected to the airspeed indicator. The airspeed indicator is connected to the pitot tube and the static port. Airspeed indicator. And this is the pitot and static system. So on the pitot and static system, like we saw yesterday, operates the airspeed indicator, the vertical speed indicator, and the altimeter. The vertical speed indicator and the altimeter are connected to the static ports. If you obstruct the pitot tube, or if you disable the pitot tube, then you're going to have an unreliable airspeed indication. And since we fly relying on airspeed, on knowing how fast the air is moving through the surfaces of the airplane, it's a major emergency. Okay? If you obstruct the static port, then you're going to lose information on altitude, and how rapidly are you climbing or descending, or your current altitude. If you are flying at night, or if you are flying on the clouds, then that can be a major emergency. So the pitot heat switch on larger airplanes also heats the static ports. There was an accident where of an airliner where they were washing the airplane, so they put clear tape over the static ports, and just to make sure water didn't enter the system. And since it was clear tape, on the inspection, no one could tell that they were blocked. Then they took off. There was bad weather, and they didn't have any altitude indication. And I think they even lost the pitot tube, because the information that these sensors were sending, they weren't sending it specifically to the instrument, but they were feeding information to a computer, and that created another set of problems, and they ended up crashing. So yes.
So pitot
Yes.
is French,
It's French.
or Henry Pitot, who invented this 1700?
1700s, and that's new information for me.
That's true?
We can find out from a reliable source, so not Wikipedia, not Wikipedia.
Named after the inventor Henry Pitot, French physicist.
French physicist.
Now, planes hadn't been invented yet, but the Pitot tube had. How did he do that? On a horse? Fall off the building?
Not the toilet, the pitot tube. Oh, and this is a reliable source, Scientific American. What is a pitot tube? Yeah. And the so apparently is, hey, bring it down. Is it started with the study of fluid mechanics, and since air is a fluid, then the application for aviation is the basically the main one for this type of devices. I don't know if in maritime. Probably ships have some sort of equivalent, yeah, of pitot tubes. Yes. And the thing with ships is that they now rely a lot on GPS because they and it's not the same in aviation, because in order for an airplane to stay in the air, we need that measurement of how fast the air is moving through the surfaces of the airplane. In maritime, if it floats, then it floats, and then you can find your location, speed, and all of those measurements through GPS. And then that's why we don't have airspeed indicators. Airspeed indicators are not likely to get phased anytime soon in airplanes, even though the technology is very old and very basic, because what we are measuring is the velocity of the fluid that we're moving in the air. And then we have the GPS that tells us our ground speed on how rapidly we're moving in relation to the ground that we're moving through. Because we can be moving on with a tailwind there's a permanent current of air on the northern states. It's called the jet stream. And airplanes, when they're flying east, they like to get into that airstream, into the jet stream, so they can have an indicated airspeed of 230 knots and a ground speed of 500, which sometimes it reaches a speed of 200 knots. Yes.
No, I just thought you said that you could track speed of an airplane by GPS.
Yes.
You can.
Yes, you can. Yes, you can, and it's one of the tools that we use. It is used in aviation, but it's not to replace an airspeed indicator, because the airspeed indicator, we use it to measure, how efficiently our control surfaces are going to be and our wings. And then you use your GPS, in order to calculate, okay, what's going to be my departure time related, to my estimated arrival. What? Yes, and then that's one of the components that we're going to see further on. It's called ADSB and transponders. And some of that information that your airplane transmits to air traffic controllers gives them that capability. And to even make a good estimate, given the weather conditions that they have and the wind reports, what's going to be your estimate at your arrival. And they can plan the, how many airplanes they can put kind of like between you and the airport. And they do that all the time. Okay. That's what a pitot tube looks like. That thing. Did you grab it from the airplane? Sometimes. Did you swing off it? Yes. Don't try. It's just grab it. Yeah, like 40 pounds maybe. And sometimes you have the static port mounted onto the pitot tube, but most of the time this is the shape that they're going to have. Or sometimes it only looks like a disc with a little hole in the middle. And what that's measuring is the atmospheric pressure around the airplane. And that's how you can measure the altitude. Now we're going to go through the, you need the previous one? Okay, you're good. Okay. The airspeed indicator, as I said, uses the pitot tube and the static port, and it compares the ram air pressure, so the pressure that's hitting the pitot tube on the entrance, and the atmospheric pressure, so it can give you an accurate measurement. So it compensates with these static ports, and it gives you a reading of your airspeed. On this airspeed indicator, you can see, for example, this white line that you have going over here. On this airspeed, this is to indicate the airspeed that you are safe to put your flaps down. Okay? So if you put your flaps down beyond that airspeed, you have the risk of provoking a structural failure, so you can rip them off the airplane. Yes, if you are reaching that airspeed with your flaps down, and you go beyond that airspeed, it's not like they're going to rip off like immediately, but then you need to retract them. Not even retract them, just reduce speed, go back to the airport, and report that you oversped the flaps. Because from that point on, you don't know if the rails that support the flaps are bent. It can cause, the flaps, they serve the function of allowing you to fly at lower airspeeds. They provide extra lift. The problem is, if you ripped off those components, it can hit, the tail of the airplane. So, you can fly without flaps. You just, approach the runway with a higher speed, and you can still land. The problem is, when something falls out of the airplane and it hits something else that is going to be, more critical, then you're going to have a different situation. So don't overspeed your flaps. Yes.
Flaps are like brakes in the air.
The flaps are, they serve the purpose of producing lift at lower speeds. So it's not necessarily an air brake, but it allows the airplane to fly safely at a lower speed. For example, if my stall speed when I don't have my flaps is 100 knots, just to put a number on it. Then if I lower my flaps, then I can fly at 80 knots and still be able to control the airplane.
Okay, so why would you want to close the flap?
Because a byproduct of lift is drag. So if you want to fly faster, then you need a wing that is more sleek and aerodynamic in that sense. So you retract them to fly faster, and then when you're about to approach the runway, then you extend the flaps.
Wouldn't the ailerons, the ones on the outer end,
Yes.
wouldn't they come with the exact same things as flaps? Like, let's say they come with flaps, right? They still reduce speed with it.
No. In theory, if they were to move at the same time, but they move opposite, one to the other. So if you move your ailerons to one side, you're going to have one aileron move down, but then you're going to have the other one move up. And then that's for turning. So it wouldn't be an option. Then you have the green indicator that gives you your normal operating speed. Then you have your cautionary range. You can still fly at these airspeeds, but you can't apply abrupt movements to the airplane, because then you risk a structural failure. And then the red radial is never exceed speed. On this one is, about 165. And we call them arcs. So you have another example of an airspeed indicator. The white arc. VFE is velocity with flaps extended. You have the green arc, and velocity never exceed. Yes?
So it's kind of like the red line in the car.
Yes.
So like you reach like 6,000 RPM. Like you can do it, just the engine
Is
run it that way.
Yes. And I had one classmate. Oh my God, this guy. So we had our first solo here in the States, in Columbus Air Force Base. And someone told this guy that we had to enter the work area because they gave us our first solo so we could go do aerobatics in the area. So loops and rolls and barrel rolls and all of that. So someone told this guy that for their solo, he had to report on the work area inverted because, he's, big macho guy, right? So he flipped the airplane. The airplane that we were flying, automatically when you go inverted, you need to maintain a nose-high altitude so you can keep the same altitude, because normally you're producing lift this way. This guy when inverted, and the airplane wanted to go this way. So there was an alert of a student pilot that when full power on a climb, and then when he saw that the airplane was coming down, he freaked out. What he should have done is to level the wings again, give more power, get to the area, and finish up whatever he wanted to do. Now this guy freaked out with full power. There is a maneuver that is called split S, to lose altitude and change direction, that you lower the power and come back down. This guy with full power attempted to do split S. The structural speed of that airplane was 246 knots. This guy went 284, something like that. So he wrinkled the skin of the airplane. Like, there was structural damage to the airplane. He was this close of getting kicked out of pilot training. So, everything was discovered because he was on radar. So there was not going anywhere. So he had to give every day after, like you fly, so you're wearing your flight suit. This guy had to, at the end of the day, at the end of his flight, go back to his room, get on his suit, on his, Air Force blue suit, and give a safety briefing every day till graduation.
I say, like, when you say you go inverted, right? You go inverted, and you're losing power, right?
Mm-hmm.
Do you still have, like, fuel coming to the engine?
Yes.
So then you would stall the engine?
No, not necessarily. We can get into that, okay? It's 3 o'clock, some buses already leaving, and yes, let's prepare for tomorrow. Quiz or test? Quiz. Test on Friday. D? Remember, as soon as you get home, get that sign, okay?
Or you lose your life for me.
Luke, welcome back.
Thank you.
Was it a good 2 weeks?
It was good. It was fun. It was a change of activity, so that's rest in a way. And it was interesting, to doing something else. Fortunately, they had me on a bit of like an admin, not doing like grunt work, but kind of like running the show in a sense. So it was 1 week. Yeah. Give me just a second. I'm gonna click. I need to do one click in here.